Why do airlines sell too many tickets? Have you ever sat in doctor's office for hours despite having an appointment at a specific time? Has a hotel transferred your reservation because it's full? Or have you been bounced off a flight and you pay for it? These are all symptoms of overbooking, a practice where businesses and institutions sell or book more than their full capacity. While often inferiority for the customer, overbooking happens because it increases profit while also letting business optimize their resources. They know that not everyone should show up to their appointments, reservation, and flight, so they make more available than actually have to offer. Airlines are a classic example, partially because it happens so often. About 50,000 people get bumped off their flights each year. That figure comes at a little price at airlines themselves, which use the census to determine exactly how many tickets to sell. It's a delicate proportion, so too few and they're wasting seats. Sell too many and they pay penalties. Money, free flight, hotel stays, and annoyed customers. So here's the simplified version of how their calculation works. Airlines calculate a year worth of information and who does and doesn't show up for destination flights. They know, for example, that on a particular route, the probability that each individual customer will show up on the time is 90%. For the sake of simplicity, we list every customer to deliver individually rather than smaller as groups. Then, if there are 108 on the plane, they sell 180 tickets. The most likely result is that 162 passengers will board. But of course, you could also end up with more passengers, or fewer. The probability for its value is given by what's called binomial distribution, which gives the most likely outcome. Now let's look at the revenue. The airline makes money for each ticket buyer and loses money for each person that gets bumped. Let's say the ticket costs $250 and is in exchange for a little flight, and the customer bumping a passenger is $800. These numbers are just for a sake example, actually amount very considerably. So here, if you don't sell any extra ticket, you make $45. If you sell 15 extra and less than 50 people are no-shows, you make $75. That's the best case. In the worst case, everyone shows up, 15 unlucky passengers get bumped, and the revenue will only be about $36,765 in the less if you want to sold 180 tickets in the first place. But what matters is just how good or bad a scenario is financially, but how likely it can happen. So, how likely is a scenario? We can find out by using the binomial distribution. In this example, the probability of exactly 195 passengers boarding is almost 0%. The probability of exactly 184 passengers boarding is 1.11%, and so on. Multiply this probability by the revenue for each case. Add and oldest the surprise sum for the hourly by 195 sold tickets, and you get the expended revenue for selling 195 tickets. By repeating this calculation for various number of extra tickets, the airline can find the one likely to yield the highest revenue. In this example, that's 198 tickets, for which airlines will probably make $48,774, almost $4,000 more than without overbooking. And that's not for one flight. Multiply that by million flights per airline per year, and overbooking at a fast. Of course, the actual calculation is much more complicated. Airlines apply many factors to create even more accurate models. But should they? Some argue that overbooking is unethical. They are charging to people for the same resource. Of course, if you want 100% sure someone won't show up, it's fine to sell their seat. But what if you lied only 90% sure? 75%? Is there a number that separates being unethical from being practical? One more. Have you ever sat in a doctor's office for hours despite having appointments at a specific time? Has a hotel turned down your reservation because it's full? Or have you been bumped off a flight that you paid for? These are all symptoms of overbooking. The practice will businesses or institutions sell or book more than their full capacity. While often impurity for this customer, overbooking happens because it increases profit while also letting businesses optimize their resources. They know that not everyone will show up to their appointments, reservations, and flights, so they make more available than actually have to offer. Airlines are a classical example, partially because it happens so often. About 50,000 people get bumped off their flights each year. That figure comes as a little surprise to airlines themselves, which use statistics to determine exactly how many tickets to sell. It's a delicate operation, so sell too few and they are wasted seats. Sell too many, they are paid penalties. Money, free flight, hotel stays, and annoyed customers. So here's the simplified version how they calculate the work. Airlines have collected a year's worth of information about who does and doesn't show up for a certain flight. They know, for example, that on particular routes, the probability that each individual customer will show up on time is 90%. For the sake of simplicity, we assume that every customer is traveling individually rather than as families or groups. Then, if there are 180 seats on the plane and they sell 108 tickets, the most likely result is that 162 passengers will board. But of course, you could also end up with more passengers or fewer. The probability for each value is given by what's called the binomial distribution, which picks at the most likely outcome. Now let's look at the revenue. The airline makes money for each ticket buyer and loses money for each passenger who gets bumped. Let's say a ticket costs $250 as in exchange for a late flight, and a customer bumping a passenger is $800. These numbers are just for the sake of the example. Actual amount vary considerably. So here, if you don't sell any extra tickets, you make $45. If you sell the 50 extras and at least 50% no-shows, you make the $48,750. That's the best case. In the worst case, everyone shows up. 15 unlucky passengers get bumped, and the revenue will only be $36,750, even less than if you sold 180 tickets in the first place. But what matters is that just how good or bad a scenario is financially, but how likely it is to happen. So, how likely is each scenario? We can find out by using the binomial distribution. In this example, the probability exactly 195 passengers boarding is almost 0%. The probability of exactly 140 passengers boarding is 1.11%, and so on. Multiply this probability by revenue for each case. Add them all up to subtract the sum from the airline by 195 sold tickets, and you get the expected revenue for selling 195 tickets. By repeating this calculation for various number of extra tickets, the airline can find the one likely to yield the highest revenue. In this example, that is 198 tickets, from which the airline will probably make the $48,774, almost $40,000 more than without overbooking. And that's for one flight. Multiply that by million flights per airline per year, and overbooking adds up fast. Of course, the actual calculation is much more complicated. Airlines apply many factors to create even more accurate models. But should they? Some argue that overbooking is unethical. You are charging two people for the same resource. Of course, if you want 100% sure someone won't show up, it's fine to sell them seat. But what if you're like only 90% sure? 75%? Is there a number that separates being unethical for being practical?